Alright, in this video I'm going to show you how we could find frequency response function of a 1 degree of freedom system using ANSYS Workbench. Alright, so let's see. Let's open ANSYS Workbench. Alright, so if you want to do frequency response analysis, you first need to do model analysis. So I'm gonna model a single degree of freedom system, a mass spring system. So let's go here to design modeler. Alright, so we go here, and now let's zoom in. Alright, so okay, so need to do a circle and XY plane. Alright, so I'm gonna have this circle to have radius or diameter of 0.5. So this has 0.5 diameter. Alright, and then let's go front view, and we draw a line, and then we trim it away, the part I don't need, like this, this, and this. And now to make the sphere, I'm gonna revolve this. So revolve this. Alright, so axis, for the axis, can pick this guy. Alright, so if I say generate, now we have that. We have a sphere body. Okay, so now close this. That is gonna act as our mass in our system. I'm gonna add a spring. Alright, so let's see. We have to wait until it opens. Alright, so you have to wait until design tree is updated. Okay, now I'm gonna go here and add a like spring. Right, losing, come here. I'm gonna connect this mass to the ground using a spring. So you have to click on this. And then for the stiffness, I'm gonna consider 2 million. Okay, 200,000, 2 million Newton per millimeter or kilonewton per meter. And for here, I'm gonna consider, let's see, how much damping I'm gonna consider. So let's consider let's consider 63,000. Okay, let me see. If I consider 63,000, 63,000. So what happens? Oh, let's say 100,000. Alright, so this is our damping. And we're gonna connect this mass to the ground. So we gotta pick this and connect it to ground. So now it's down, it's connected. So we can mesh this model, generate mesh. Okay, and then solve it to find the mode shapes and natural frequencies. This is a single degree of freedom system. Technically we should have one, but you're gonna see here that we have multiple solutions. Some of them are rigid body motions. They're not actually you know, they're like fake natural frequencies. So in order to eliminate those, we can limit, because this right now, this is like a, okay, let me show you. If I want to show you guys the mode shapes, all of them, you're gonna see some of them are actually right, rigid body motion, so they are not vibrational mode shapes. So look, this one for example, right? In order to eliminate these guys, what we can do, we can forcefully limit the motion to XY plane and along Y. So let's do that. To do that, you come here, you say insert, and then say displacement, and then I'm gonna limit displacement in X direction and also in Z direction. And for geometry, I'm gonna just pick everything. So now let's see what happens. If I repeat the solution, you're gonna see those close to zero or zero natural frequencies are gonna be eliminated. Alright, so look. Now I have, you know, the first one is the one that we wanted to find, is the relevant one. The other ones again are like junks. So let's see them, what they are. So this one is the one we expected to see, right? For a single degrees of freedom system, this is what we expect to see. Alright, the other ones, yeah, it's like, it looks like these are not right ones. Okay, so the first one, we just need the first one. I'm gonna eliminate these guys. Alright, so delete those. So can just say find one mode shape. You can say it here. Then you're just gonna get the only mode shapes that is relevant to our work. Alright, so it's a mode shape. Alright, so next I want to show you guys how we can find frequency response. So how to do that, you come here to analysis, and then you go harmonic response. So and then come here, analysis, setting. You can define the domain of your frequency response analysis. My natural frequency was 300, so I'm gonna do it from, let's say do it from 200 to like 800. And then solution intervals, this is like resolution for us. So I'm gonna do, let's say 200 to 800. It's like to do 600. Alright, so and then here I'm gonna output our frequency response of the formation. Alright, so it says what geometry you are interested in finding frequency response for. You click on this and then say you've clicked that phase. And then, by the way, frequency response analysis needs a force. So we need to know what force you're looking at and also what point you're gonna apply it to. So come here, component. So it's gonna be in Y direction. So the magnitude really doesn't matter, but so it's 1,000. So gonna apply it to this guy. So now let's run it. So let's run it. Alright, so let's see. It's coming. Alright, so it's coming. Alright, so you see, depending on the resolution here and the range, it's gonna take longer time. If you have like very fine resolution and you have a wide range, that's gonna happen. It's gonna take longer time. And my laptop is not really top notch, it's not a state of the art. So our natural frequency is 313. So we're gonna see a peak around that. Alright, so let's see, 70% done, 73, 74, 77, alright, so getting close. Yeah, if you wanna see a smooth. Oh, by the way, the frequency response, I made one mistake. I should have had the deformation in Y direction, so we have to fix that. Alright, so we have to, that's not going to be useful because it's in X direction. I forgot to adjust it because that one dimension that we are considering here is the Y direction. So yeah, okay. This is not what we're looking for. So let me change this to, it's similar to what we're gonna see. Well, let me see, it's in Y direction, so everything frequency response to deformation must be done in Y direction. So let me come here, I have to fix it to Y. Yeah, alright, so let's see that. We gotta wait again. Oh, that one was quick this time. Yeah, alright, so let's see. So it looks like the solution was done in all directions already, so that's why it was short. Oh, no, I'm sorry, I made mistake. Go here, insert, not deformation, we should see frequency response. Frequency of deformation of the geometry. Y, and then right click, evaluate. Alright, I hope this time, yeah, it was done faster because the solution was done before. So alright, so let's look at it. This is like the response, the amplitude, and here's the phase angle of the response function. This technically tells us, the phase angle tells us the phase difference between the input and output, and this one tells us is like the amplitude or the magnitude of the response. Alright, so this is how it is done. So I hope you guys found it useful. As you see, there is a peak at 313, around that point. And with my damping, this is the response. If you change the damping, the response is gonna change. So if you'd like to, you can play with the with the stiffness or the damping, and you see the change in the response. Okay, just one test I want to do. If I do it 1 million, for example, like we made it 10 times larger, 10 times larger damping. So let's see what happens to the response. Yeah, so it's gonna need to do a fresh analysis. That's why it's gonna take again longer time. Yeah, alright, so see if I can the phase angle and the response. Alright, so let's see what happens. Well, our expectation is this curve to come down, with larger damping. See what happens. the smaller damping is gonna increase this peak here, and in theory if you have zero damping, that's gonna be infinite. Should have infinity here around the natural frequency. So let's see what we get. If you like, you can later make similar model and then play with that. The table, by the way, there's like a table here for amplitude and phase angle. You see, if you like, this is actually the result in a table format. If you like, you can export this, right click and export, and then take it to Excel and plot it yourself in Excel if you don't like the way ANSYS is plotting. So let me do it, frequency response XLS file, so we can save it and then open it there and play, so you see it's here, and if you like, you can plot it here. I don't know if you don't like this is the frequency, sorry. So the amplitude, if you want to do that, come here, there's the function. See, we have like a peak around the natural frequency, and then it goes down. You need to do it log scale, the axis, and here you need to do it log scale. Let me see how we could change this here. It's probably, let me see, and see if I remember where I could change these to chart design. Okay, is it here? The axis, primary, horizontal. Let me see. Once you double click here, you should. Alright, let me see how we could change this to. Oh yeah, logarithmic scale is here. Yeah, so if you do it in logarithmic scale, your curve is gonna look much nicer, the frequency response function. Alright, so this is how you guys can do that. You can export the result into as I said, to Excel, and here's my new result. Is it the new result? Seems like it. Yeah, so probably with larger damping, what happens, that peak is gonna come down, that's what you're gonna get. Alright, anyway, so my main intention was to show you guys the process of finding frequency response. Oh, it looks like we need to refresh everything. So anyway, so I just wanted to show you the process. I hope you find this useful, this video. Alright, so that's about it.